Okay, the modal class here is the one which occurs most often. If we look at the frequencies, the highest frequency is 60, so the modal class is this one, which is 60 to 70 kilometers per hour. So this is a question about vehicles passing a checkpoint. So the most common speed is 60 to 70 miles per hour. Okay, so we're now going to estimate the probability that the next vehicle has a speed of 60 kilometers or less. Okay, if we look at this question, we have 180 vehicles, and of those vehicles, the ones which are travelling at 60 kilometers an hour or less are these ones, the 4 and the 52. So the probability, and it is only a probability, that the next one that comes along is going to be going at less than 60, is going to be 56 out of 180. You can simplify that if you like, or you can just leave it like that. Okay, cumulative frequency table then is quite straightforward to fill in, and it does help because they actually give you what it means. So how many cars are going between 40 and 50? Well, that's obviously the same 4 here. How many cars are going between 50 and 60? This is actually incorrect in the table. Should be cumulative frequency is next. The next one is 56, so that actually should say 40 to 60. All of these lower class boundaries should be 40, just to help you. Otherwise, it's the same table as the one above. So anyway, mistake in the paper there. Next one is 56 plus 60. Well, that's 116. The next one is 116 plus 34. That comes out as 150. 150 plus 18. That's just 168. And then the last one is 168. And the last one, 168 plus 12, takes it up to 180. Make sure that your total here, your final number here, is the same as the total of the frequencies, which you're usually told anyway. Okay, we next have to plot a cumulative frequency graph. Now always, because cumulative frequency tells you, in this case, the number of cars that travel at less than each speed, you need to make sure that we plot in the correct place. So first of all, we have 4 cars that travel at 50 kilometers or less, so I'm going to put a 4 here. If we check out the scale on this vertical axis, I've got 5 squares equal 20 cars, so each little square is actually equal to 4, so 20 divided by 5 is 4, so we've got 4 cars travelling at less than 50, so that's 1 square. We've got 56 cars travelling at less than 60 miles per hour. Well, 4 goes into 50. Well, actually, it's easy enough, isn't it? So we've got 56. That's just going to be no, 2 squares. Sorry, 2 squares below. 70. That's the cumulative frequency. There is 116. So 70. So I'm going to go up to 116. Well, that's 4 less than 120. 80 is 150. Well, that's easy enough to do because it's exactly halfway between 140 and 160. Less than 90, that's 168. So 160 plus another 2 squares, which is there, and 100, that's our final 180. And strictly speaking, we should go through 0 here. Okay, so that one was wrong. Join them up. You can either join them with a ruler or with a smooth curve. In this case, pretty smooth curve. Not too bad. Question says then, any driver passing at more than 84 kilometers per hour is going to be fined. So how many drivers would they decide to fine? Well, we find 84 kilometers per hour. So 80 is here, 90 is here, 84 then is just 4 squares. I need to use a ruler to get this right. So 84 starts here. Oh, that's not a ruler. Let's just undo that and use a straight line this time. So 84 is here, so we go up to the graph, go across, and it comes out as about, on my more accurate version, it's about 156. It's not particularly clear there. So this is about 156 over here. The number of drivers who go at more than 84 kilometers per hour, though, isn't 156. It's 180 less 156. Which is about, so this is only approximate, about 24 drivers.